Welcome to the use case of Siemens in the context of the aerOS project. The objective of this use case is to stabilize a flexible production system supported by aerOS, modularity, efficiency, and flexibility. As we have mentioned, we want to have a line production that is able to modify its functionality and its organization depending on the final product. This change should be dynamic and automatic, so the line will be able to fabricate one different product each time. For that purpose, we have 4 AGVs with an integrated lifting unit, so they can move the robot arm or the boxes to the correct position. With this, the layout of the fabrication line will be different depending on the product requirements. To be able to do that, each AGV has a navigation module developed by Siemens, and there is a Siemens Fleet Manager in the server. When the box and the robot arm are prepared, the robot arm starts to recognize the products in the box with an AI application, and it puts the product in the correct box. In the meanwhile, when one AGV is running out of battery, it could go to the wireless charging area. Once the boxes are prepared with the final products, the AGV moves them to the correct zone and sends a command to open the door so the user can pick up the products. Right now, without aerOS, each service is running always, reducing the performance of the process and the availability of resources. For example, in the AGV, the navigation service is running even if the AGV is charging or waiting to the box to be filled. In the same way, the robot arm has the AI application running even if the robot arm doesn't need to recognize the environment at that moment. Even more, the AI application needs to be run in a Linux distribution, so we need another device for that. Without aerOS, we need to run everything locally, so the performance of the AGV will be lower because of the amount of services running on it. With aerOS, these problems are solved because it decides by itself when and where to run the different services. So for example, the navigation and the AI application could be run only when they are needed. By this, we obtain a high availability of the AGV, having more time for doing other tasks or charging. Even more, as aerOS will be run in a cloud, we won't need a dedicated device in the robot arm to run the AI application. We would just use a service in the cloud and communicate it with the robot arm. About the topology, the aerOS entry point will run primarily on our local server. Optionally, the management portal with the entry point balancer and some auxiliary services could be run in an external server provided by Sce3. As can be seen in the topology, there are PLC devices that can communicate with Siemens devices and services, as well as aerOS services over industrial protocols like OpenCUA. We plan to bind the aerOS framework with our Siemens Industrial EDGE, a ready-to-use edge computing platform which will run in our local server. Additionally, Siemens provides the service allocation algorithm in aerOS. The aerOS Continuum consists of heterogeneous networked infrastructure elements with resource constraints and hardware capabilities, which allow on-demand service execution. To execute a service on an IE, the allocator needs to adhere to computational and hardware constraints while, for example, minimizing the overall power consumption of the continuum. Since service allocation is NP-hard, conventional methods like mixed integer programming struggle to find an optimal service allocation in under 2 weeks. We work on a reinforcement learning model with a neural network that lowers the execution time significantly to under 1 second in preliminary results. However, we don't stop at providing advanced machine learning models for the orchestration of the continuum. Instead, we develop a holistic methodology framework for developing and designing machine learning applications in an unified and automated fashion and apply this concept already to the orchestrator model. By this, we ensure the resilience, the computational scalability, and a zero-touch operation of the orchestrator model. So to summarize, at any time, aerOS will decide where and when to run the different services, depending on the available resources, improving the performance and the optimization of our flexible production line. Thank you so much for watching us.